domain and range. But this time we don't have a graph. We have a defined function. It's written out for us right here. This question is asking for the domain. And so how do we find that? Well, it's important to know that this is in the form of, we call standard form, which is ax squared plus bx plus c. And that's important to know because the a tells you whether or not the function is opening up or down based on whether or not it is positive or negative. This one is clearly positive because there's no number there. That means you know that there's a positive 1 right there. So that means we're opening upwards. Now remember, domain concerns the x-axis. So let's think about the x-axis. It looks like all of these x values are on the graph. We don't know this x value, but we know that all of these x values would be on it that way. And then we can continue on. And all of these x values would also be on the graph. And all of these x values would also be on the graph. And because these arrows are right here, that means the graph is going to continue going left and right, which means our domain has to include all real numbers. The domain is the easiest part with quadratic functions, my stews. The domain will always be all real numbers for quadratic functions because you can plug in any number you want into those x values. Well, any real number you want. But now let's consider range. If you're given a problem like this and it's asking you for the range, you have to do a little bit more work. Okay, so as a reminder, this standard form is ax squared plus bx plus c, and that's very important because that tells you, the a tells you whether or not the function opens up or down based on if it's positive or negative. If I'm looking at the a on this guy, we can see that it's a positive number. It's actually a positive 1, and that's why you don't see it, because 1s can go invisible, because when you multiply by 1s, it doesn't do anything to the number. But anyways, so we know we're opening up, and we know that we're trying to find range, which means we need to know the y values that are going to be on this function. If I look at all these points right here, all these y numbers, we know that all of these, starting at this bottom one and up, will be on this graph. But what is that bottom number? That's important to know. Well, if you guys notice, that's the vertex. Okay, so let's talk about finding the vertex. But first, let's talk about how we're going to write the range. You would start by writing this set bracket thing, and you would say that the range are y values such that y is greater than or equal to some number. Okay, so we know that we have a greater than sign for our answer. So we know it's definitely not this one. But we need to know what that number is. So let's find our vertex. To find our vertex, we first are going to need to find the axis of symmetry, which is negative b over 2a. And when I plug in the b and the a, I get negative 16 over 2 times 1, which is negative 8. And so our x value is negative 8, which I don't care about because I need a y value. I need to know what the y value is when we're at negative 8. And so I'm going to have to take that negative 8 and plug it in. Oof, I can't see it right there. So let's erase this up here and then plug in a negative 8. All right, negative 8 squared is 64. And then, I have to go 16 times negative 8. I don't want to do that. Plus 64, well, I have to do that. So I'm going to do my math on the side, which I highly recommend so you don't make mistakes. And it looks like it's negative 128. So I put negative 128. I add the two 64s together. Don't forget to write stuff out so you don't make mistakes. And then I get 128 plus negative 128, which equals 0, which means my y value on the vertex is 0, which means this number is 0, which means my answer is that guy. All right. So just as a reminder, if you're only looking at the signs, you know right away that this one is not correct because our sign has to be a greater than sign because we're opening upwards. And then we also know it's not all real numbers because all of these numbers down here aren't included in the range. So our answer is obviously that one.